Well-Architected Solutions on Twitch. I'm Julio, your host, and I will be here with you for several episodes getting an update on the AWS Well-Architected framework, what it is, how it is structured, and how can it be implemented. The most important thing is turning this from best practices and strategies and the abstract vision that you have from the artifacts on the AWS Well-Architected website and turning it into actual implementable solutions with code that you can read and understand and deploy it as it is or customize each individual solution to help you through building your own architecture. So I've been doing this for a couple of years now. I'm part of the AWS Evangelists team. We are here helping developers be successful with AWS worldwide and not only in developer events and conferences, but here on Twitch with you, live coding these things and making sure that everybody everywhere has access to this information, concepts, and most importantly, direct access to us as we are frequently moderating the channel and helping you guys with answering questions, and everything you want you can get either on the Twitch channel, ask us on stream, and also on Twitter if you'd like. I'm Julio AWS on Twitter as well, and I would be very glad to see you there. So let me switch to the actual AWS website where we can find more about the white paper. I'm going to log into the Twitch channel as just so I can see the chat and keep a conversation with you all. So at any point, if you want to ask anything, just use the Twitch chat and I will be able to see. Perhaps if it's in the middle of a subject, I may not see it right away, but I will get to every question and answer everything as quickly as possible. Okay, so let me just send a message here for you guys. Hello everyone. So yeah, that seems to be working pretty fine. Okay, so changing now to the website. Let me show you guys a little things. So this is the AWS Well-Architected website. Here you can find links to everything we're going to talk about in this series. And the most important part of the Well-Architected framework is understanding why it is for. So it is built for you to deploy and build faster, so you don't have to research your architecture from scratch. You have a baseline to start with, and you can certainly mitigate your risks of not having the right information about security, about scalability. So you know that feeling you get when how can I say, the fear of missing out on architecture decisions. So is everything done? Is that everything enough? Like you can, of course, that for many things you can load test, you can use your load generators or perform unit tests and make sure that everything works, but how can you make sure that it is enough? So the well-architected is certainly not everything out there in the universe, but is a comprehensive base of best practices we collected over and over from interactions with customers. And you can feel pretty confident that if you pass an AWS well-architected assessment and understand the answers that you give, you'll be pretty confident that you're not doing that bad. Of course, that every business will have different characteristics and may have different questions, or not everything in the framework may be fit for them, but you can be sure that at least you understand that was your responsibility, and you may choose to implement it later or sooner, but that's how the framework functions. So it's not about everything in a single paper, but there is a master well-architected white paper PDF, and this is what we are going to use most of the time today. So this is the white paper. I have it open on preview here, and this is where our guidelines and questions and best practices are stated. And you can see that the AWS well-architected framework is divided in 5 pillars. So the newest pillar is called Operational Excellence. And operational excellence is about operating not only systems, but operating software processes. So aligning software development processes with business objectives, and being able to monitor those systems and execute them and provide insights from them, I think is the key to understanding operational excellence. But this is just preeminent because it's the newest pillar that we have. We will actually start with our job zero, that is security. So security will be the primary requirement, and because it's, as we usually say, business ending criteria. So if you have a leak on your user base of personal information, you may be in serious trouble if you're in a regulated environment, or if I'm sure you are aware of many outages and leaks that caused significant issues to their business, and the cost of availability and privacy today can be really, really high. So security is going to be first and foremost in every architecture nowadays. Then we're going to talk about reliability and see how we can make systems keep up with expected and unexpected changes, and throwing every kind of circumstance at the app and making sure that it's still running. Performance efficiency will show us that this is performance efficiency not only in terms of the app, but also in terms of the whole process. So how to select the best compute process. For example, we have several compute solutions, and well, sorry about seems that I have some audio issues here. I think that let me just double check that everything is working well. Can everybody hear me okay before I proceed? Just let me double check this. And we really tested this thoroughly, but it seems that we are having a couple issues. So let me just double check it. Okay. Sorry about the audio quality issues. We can get back and review everything that I just said. I want to make sure that this works perfectly for everyone, especially because this will be kept as a reference for the future. So let's try it again. I will increase my volume here. Let me just make sure that I can hear the same as you guys. I'm sorry, truly sorry to do this live, but as this is live TV, I can see the why it is. I will have to stop this and change it, and we'll get right back. Okay. Just a second. And let me just wait for anyone on stream to confirm that they can hear me properly before we come back to the subject, and I will restart from the top, don't worry. This was just a very fancy audio interface, but for some reason it only could do the left side, but luckily I had a separate controller. Can anybody there on stream tell me if this is working okay? I'm just refreshing, seems to be live, and from what I hear, it is perfectly okay. So, how does it sound to you guys? Yes, I can see myself now. I just reloaded the thing, and awesome, great to hear that. So I'm truly sorry about the delay again, and let's resume talking about the AWS well-architected framework. I will go straight to the website and show you guys what I was telling you right before, but this time in a much better situation technically. So this is the AWS well-architected web page on Amazon's website. You can find that with a quick search, or awsamazon.com/architecture/AWS well-architected. Let me paste the link to everyone on the browser, and here you go. So there it is. With let me get the monitor a bit away from the fan, but those hot MacBooks, the fan is always going to be there for us to hear. Sorry about that. But anyway, the AWS well-architected framework is designed to help everybody deploy good architectures in terms of security, of performance efficiency, and other pillars that we are going to see. But the idea is, especially if you are new to this, to software architecture or to engineering in general, how do you make sure that you keep your job, right? How do you make sure that you have your grounds covered in those requirements that you may not even know what exactly they are? So we face this situation a lot with many customers, and we collect those requirements and those experiences, and this is the well-architected framework. And so I hope we can learn from our best practices and see what it looks like. But most importantly, we want to build using this approach. So I will take the time in this series to code every best practice that we see in the framework. So I want to show how that actually looks like in code most of the time. So if we are talking about cost efficiency, for example, we may talk about serverless. We are going to actually code some Lambda functions and see how that can actually be built, right? So The most important artifact here on the AWS well-architected website is the framework page, the actual white paper. So here in this PDF you can download. I have it open here on preview, and this is the text that we are going to be following. So it is very important that we familiarize ourselves with this white paper, because we're going to use it most of the time and make references, and we jump back and forth on it, and by the end of this you will be completely through with this white paper, and we will certainly understand not only the text but the concepts and the examples that are behind it. So, well, the pillars, the non-functional requirement types that are going to be part of the pillar, the framework, are divided in these sessions. So the first requirement that we're going to see in the series is security, because this is actually, as we say, the job zero. And we know that security is not that romanticized hacker versus good guys that we see in the movies, but the idea here is to automate security. How can you make security an automatic part of your software delivery and guarantee that the outcomes of your software processes are safe to be put into production? And that the mechanisms for that is what we're going to see in security pillar. This is the episode coming up this week, and if you ever find, if you want to check this again or not sure about the schedule, on medium.com/JulioAWS we have the initial post for this series with these exact dates. So today is the framework review. On August 10th, in a bit of a weird timing, as we're going to have the security specialist Ben Potter joining us. This will be on a different times, but all the other episodes follow the same times that we are seeing today. And then after that is going to be the reliability pillar. The next part of the framework is to make sure that the system can self-heal, to adapt from both failures and other unexpected events. So a server could fail, you could have even success in terms of marketing, or have a publication somewhere that throws you a lot of traffic, so you may need more compute resources and things like this. And this is the kind of thing we'll see in the reliability pillar. Then we're going to see some performance efficiency tips, and this is both in terms of engineering performance, meaning like high speed, high throughput, low latency, and accelerated compute, and other things to match performance standards, but also to make sure that your process can select the best technologies at every point. So, for example, just in compute technologies, we have serverless compute with Lambda functions. You can use serverless containers with Fargate. You can use managed containers with ECS. You can use Kubernetes containers with EKS. You can use regular EC2 instances with Amazon EC2. So, what is the right thing for each scenario and how to balance and think about the solutions is what we are trying to figure out in this series. So in this chapter, and finally the cost optimization trick, and pretty simply how to save money on your AWS bills, in terms of networking, how to use CDNs for caching, for generating less load on your backends, and for the loads that get to these backends, how to make it simpler, like how to make it lighter and how to process things more effectively, and leverage the AWS services that have the best sympathy in terms of costs with what you're trying to achieve. And we're going to see that this reflects a lot in architectural choices that you can make. So cost optimization is going to always be mentioned, and we are going to always be thinking about that a little bit as well. So that's it for the pillars, and I guess that's pretty clear for everyone. And following, let's go through the framework and starting understanding each thing and each component of the framework, let's say. And besides the best practices themselves, this framework also sets some general design principles. So roughly speaking, the two most important body parts of the AWS well-architected framework are the general design principles and the best practices that are posed in terms of questions. So here in the first general design principles, those are valid all through the framework. So stop guessing your capacity needs and start adapting to your infrastructure requirements, to your users, to your traffic and things like this. We are going to see how to test systems at production scale. So if you expect 1,000 users per day, don't test it with one. And we all seen that movie where developers develop something that looks excellent in the lab, but once it's out of the door and hits production scale with, I don't know, I worked primarily in government systems, so systems that were open to the general population, and on the day you open the doors to the system, it's hundreds of thousands of people coming in, and you may have to be prepared for that. And in government systems, it's easier because you usually know these dates, but if you don't even know these dates, just getting it is, maybe harder, so just adapting is much easier. So automating to make architectural experimentation easier. So this is something we'll do using a service called CloudFormation mostly, and this is the key to automating every step in our software delivery process. We're going to make sure that everything is made by code and that can be easily replicated. So if you need more environments or environments in different regions, you can Okay, so just checking for questions. And now another thing is allowing for evolutionary architectures. And this is the theme of not creating our architecture perfect from start. This is not realistic. As you know, we're going to see in existing applications, even if you already have a code base, how can we make better and change it and make sure it adapts to our needs, right? So that's evolutionary architectures. If you're interested more about this, I highly recommend looking into Rebecca Parsons' slides. I will check some references here. So it's Rebecca Parsons. I will just leave it here for you guys and making sure I get this reference, because all these links that I'm sharing with you and everything that I show you here, I will collect and get it on paper, and so we build and share and create a body of knowledge around this well-architected framework. And this is going to be all in a GitHub repo that I'll be sharing with everyone. So then we'll drive these architectures using data. So this will be based in metrics and collections, and we're going to be very quantitative in our evaluations and trying to measure this with as many numbers as we can. And we're going to exercise some game days, and for example, taking a day to shut down instances, inject defects, inject latencies, and see what can go wrong. And this is the way we're going to go for all of the pillars. So as you see, that most of this is different than what people usually think in regular data centers, right? When you're going to test your systems, you may not have enough capacity or physically on your data center, but on the cloud you can just spin up a test cluster the same size that you intend to have at production, and just pay for the seconds that you use of that. So this makes it much easier to run those things. So we are allowing for architectures to be evolvable, not that thing that once it's done, don't touch it, never change it. So we're going to see how we can automate the delivery of the solutions, so that we can, in time, keep adding components, changing the architecture, and making things happen. So let's jump into the 5 pillars and seeing how the framework works. And the most important part here is understanding each question. So the best practices here will be divided again in design principles and questions. Let's just first go through the design principles of operational excellence. So this is specifically for the building your software process part of the framework. So this is not so technical and implementable solutions as we have in performance, for example, but are important things to think about anyway. So performing operations as code, as we mentioned, everything will be done in CloudFormation templates. So this is the second time we're mentioning CloudFormation on stream. So I better show you guys what it is and how it looks and what it is to perform operations as code. So here on AWS's website, let's go to my aws.amazon.com. So this is the main website. I hope you're all familiar with this. And in my account, if you have an account, you can sign into the console. If you don't have an account yet, you can go to /free. And on AWS Amazon.com/free, you'll find the way to create your free account and get started with the services. As I already have one of those, I hope you guys too. You can just log into the services. And by the way, if you need anything, if there is any other thing you need contact or help with AWS at all, feel free to contact me at any time, and I would be glad to help. So here is the CloudFormation console, and let's see what we have here. Here I have some applications that failed to deploy in the past and some things that were successful. Let's try creating a new stack. So to create a new stack on CloudFormation, we can just create a stack here or design a template if we don't have it already. So let's try to design a template and see how it goes. So the template designer is just a tool to help you if you don't remember the names or the syntax. It can show you the language here, the actual JSON, the actual code that gets built. Let's try to start with just one. I think the simplest thing we could create here is probably an S3 bucket. So let's try an S3 bucket. So if you don't know S3 is our storage service, and the basic unit of storage is a bucket. And I have a bucket here, and here I have the properties that I can add to my bucket. Let's see if I can open this somewhere. And here the component types in JSON, in YAML. You can choose whatever language you prefer. There are some advantages. YAML is a bit more concise, so I would do this in YAML. And this is one way to work with CloudFormation templates, but to be honest, not my favorite. And let's close this and try to build it from other sample templates. So this could be, I'll just open a code editor and try to build it, my first template here. Or while that loads, I will certainly need the documentation website. On AWS at amazon.com/CloudFormation, you can find all of that. Oh, I can see the stream stopped for me. I hope it's still going well for you guys. Let me know if there is any streaming issue at all. It seems that it is caught up. So here on the Getting Started resources, you have a link to the CloudFormation docs. And this is very important because this is our dictionary for the CloudFormation templates. So see, working with AWS resources and the CloudFormation APIs and all the resources are available. All the links are available here. Let's get to resources. Here it is, the documentation and the sample code and sample templates. This is really fundamental, and I'm trying to get started with the most basic resources as possible to make sure that everybody understands the whole idea of creating resources with code. So we just started seeing the well-architected framework, and as we talked about it several times in provisioning things automatically and running resources with code, I'm showing everybody the AWS CloudFormation tool and how it works, because this will be certainly used a lot in this series. So I started showing a bit of the designer and things that you can use. There are several tools like that, but to be honest, the sample templates and template references are the things that I prefer to work with. If you like the designer and other tools that are available, you can use whatever you like. So the template reference here in the resource types property here you can have all the AWS resource types. So as I was mentioning, I was looking for an S3 bucket. So this is here on searching for 2 dots helps to find the service because they're always prepended that way. So here on the AWS S3 bucket, you can see the exact syntax for the JSON if you're into JSON, or if like me you prefer the YAML version of this. Let me remove myself from the video so you can see the full text, the full code. So here is the full JSON for this setup, for this bucket, and the YAML for the same thing would be here. So in this code you can set the bucket name, the configuration, the lifecycle, the tags, everything that you need for your bucket, and the code sample. So here is the one example of a code bucket, including a bucket policy, retention policy, and things like this. Or the same thing in JSON format. So you can see that the YAML format is a pretty easier read, right? So I hope that up to here it is okay. All right, I can see that we have some questions here. If there is anything at all that doesn't sound okay, please let me know. This is an interactive webcast. I would love to hear your feedback on everything. So if you're just starting now, we are reviewing the AWS well-architected framework and starting with the operational excellence pillar. And we've been talking about performing operations as code. So I decided to stop for a bit and show you how that works in CloudFormation, because that's the service we're going to use a lot on this series. So I got some CloudFormation example of one of the things we can create. That would be an S3 bucket. S3 is for example, our storage service, and use it a lot. Every kind of data that you would want to store on AWS, you can store on an S3 bucket, and this will be a central point for data integration and things like this. So it's probably a good idea to learn how to create an S3 bucket with code. So that's the way to do it. And one important property is here the bucket name, for example. Let's add a new file, completely new project here, and let me copy that template from below. So this is a YAML template for CloudFormation, and it looks all right. So I will call it first bucket YAML, and let's take a look at the actual code. What is this doing? So it's going to create an S3 bucket of type S3 bucket with an access control of public read. It's going to be called a public bucket. So let's change the name. Let's call it my first Twitch bucket, with a website configuration saying the index document will be index.html, with error, with routing rules saying that requests routed to this place or that place will be routed differently. This is too much for now. Let's kill this this bucket, and a deletion policy of retaining this bucket if this stack is deleted. And in the end, the website URL and the secure bucket URL if you want to access the site using HTTP or HTTPS. So this is looking good. Let's create this using the CloudFormation Management Console. So I will call the create stack operation. I could have designed the template, or I will upload it to S3, or just specify a URL. So let me get the one I just created with you. And upload it. So it's called stack01. And here it's any property that you want to add to your stack, saying for example that the owner of this is Julio and his email is jfireman@amazon.com, for example, so that you don't miss. If you find this, you don't keep yourself wondering who's this environment from, who's off, and things like this. Who's paying for this? Everything you want, you can add this as key values. We are going to investigate a lot about CloudFormation and things like this, and further settings. But for now, let's just create this with with the regular initial settings. So here is the a rollback in progress. Our bucket name should not contain uppercase characters. So that's something we made wrong here on the bucket name. My first Twitch bucket. And now I can create stack again, upload the new first bucket YAML, and let's call it stack2. And create. So it's going to be in creating progress. It's trying to create that bucket for us. And in a bit, we have the bucket created here in stack2. In the resources, we can see the S3 bucket was created, and if I click this hot link, it will bring me to the AWS console. Okay. So this shows how to declare the resources with code. So I just came here to my cloud. Let's call this second bucket, as I'll create once again, just for us to check something. I would like to show you guys that this is not only for the console. You can do the same things here on the CLI. So let me show you doing the same thing, but from the command line. There is a set of tools called the AWS CLI. In AWS, amazon.com/tools, you can find the link to this. So, or directly under CLI, as that would be faster than clicking the other link. Here is the reference to everything we just did on the clicks. We can do it with the command line. So one option, as this is just a simple bucket, we could have used the command line to go to S3 And there is a command to create a bucket. It's called mb. So this creates an S3 bucket. So, but if you think an architecture that has more than a bucket, it has like 10 buckets, several kinds of servers, you're not going to do several commands, and if one fails, you do rollback management and things like this, because CloudFormation does this all for you. So instead of doing all these commands, we can just declare everything in CloudFormation and use CloudFormation to create the stacks. So here we can use the same button, the same command, the same API that we had before. It's here on the command line. And others, for example, the describe stacks. So describe stacks will bring you information about your existing stacks. So if I do AWS CloudFormation describe stacks, oh, I have to set my profile. So you see the command returns a JSON with all the data from our stacks. So our bucket that we just created should be here somewhere. So here it is. So the stacks has a stack name stack2, it is create complete, and the output key S3 bucket has the value of my first bucket.s3.amazon.com. So this is my bucket URL. So if I create a file and upload it there, you could find it under this name. Okay, that's it. We're gonna do this in just a little bit. What I want to show you is this here, this view on the CloudFormation website. It's the same information, it's the same web service being called as you have here. Like it's the same thing. It's just two different clients for the same remote web service, and that's why you can do things either by the console or the CLI or even other tools. So let's do it by the CLI. So using the create stack. So let's check what are the arguments that we need to pass to create stack. So through a create stack, you have to pass a stack name and either the template body or the template URL. So let's go with stack name stack 03 and stack and template URL file, or I think I can just do the name of the file is my first template.yaml. What's that file called again? First bucket.yaml. The tab completion in this terminal is a bit slow. First bucket.yaml. Let's see if this works. Oh yeah, it must be URL, it's for Amazon URLs. So this is the template body. Unsupported structure. Is it like this? Yeah. So you have to pass the template body as a URL, and the resulting thing is that my stack was created, and if we go to the CLI and run the command again, or go to the CloudFormation console, we see our stack tree being provisioned. So and should be achieving the same thing. So here on resources again, we created another bucket. So if we have a new file called hello Twitch, and we save it as an index HTML, we can upload it to this bucket. And interesting thing is the objects, like the content of the bucket, just like the content of your server, is not something that CloudFormation will help you with, at least by now. There are a couple ways to add it in. You can add it as a custom resource or do it outside in your app. So we got the index uploaded there and a simple HTML file. And here in the output section, you can see that my template right here, there is two sections right now. This is a very simple template, a resources section and an output section. And the output website URL fetches attributes from the resources it creates. So this is a pretty important CloudFormation concept. So on the stack tree, you can see here the website URL property. I can click on it, and I can see the error because this key doesn't exist. So it got I probably got a wrong name for the key there, but the important part is not about the bucket, it's about the CloudFormation. You can see that in this property name, here it already has the correct bucket URL and the correct website domain, because in the template, it makes this get attribute. So here I'm calling the get attribute function, it's a CloudFormation intrinsic function, to fetch the S3 from this S3 bucket object. So this binds to this name. So if I had any other name here, it would be this name. And the property is website URL, as you can see here in the CloudFormation reference, in the bucket type. In every CloudFormation template, you will see here in return values, you can see the properties that it returns, that you can fetch with ref, that is another function, and with get attributes. So you can get the ARN property, the domain name, the dual stack domain name, and the website URL. So again, this website URL property is the S3 website endpoint for this specific bucket that we created. So doing this, you can create things automatically with code, and in the same way, you can export like what your code creates, what your stack creates to other stacks. And this way you can put stack on top of stack on top of stack and make sure that all of your architectures are defined as code. And here you can see you can make changes in this stack. You can update this stack, you can delete this stack. So if you have changes to your architecture, you can just you can create a change set and see the changes that it would make comparing your new template with the running stack, or you can directly update the stack and ask, hey, CloudFormation, please make the update, and it will look for every property and change the configuration of your resources to match what's declared on the template. And one important thing is here on the documentation, another important detail is understanding what each property does when it's updated. So for example, if you update the bucket name property, it would require replacing the bucket because the bucket can't change the name once it's born. So if you create a new bucket, it will actually create a new bucket and replace the old one. But other configurations, such as the course configuration for cross-origin requests, this can be changed without interruption. So if you change this property, you can expect no downtime and things just keep running as it is. So that's the kind of thing that it's a bit hard to see in the designer, and this is why I said the designer is very good to get started and start seeing some code, and if you don't remember the names of the properties in the JSON, just get it quickly started. But it is important to dive into this documentation and understanding how CloudFormation works, and how do you find out if updating something requires intervention or not, requiring interruptions or not. Sorry. So just for a review, we are streaming for about 1 hour. It's a good idea to review things a bit. Let me get back to the AWS well-architected framework, and that you guys show me again, see me again. I'm still here, and as you can see, we just had an overview of CloudFormation because that is, we talked about it on the pillars, and that's the overall way I want to go with this series. We are here talking about the well-architected framework, and that's a way to understand architectural best practices and make sure your architecture is ready and complies with the non-functional requirements that your company has and that we see in many customers. And starting with the performance excellence pillar, we talked about performing operations with code, and we saw that in the general design principles. So I thought we'd better give it a show and see how can you do this thing of perform operations with code. If you are a veteran of CloudFormation, and I'm sorry, I know that I have a few colleagues watching this and may know much more of CloudFormation and performing operations with code, but I'd like to make this really friendly and create this reference, so in the future when we are doing more advanced stuff, we can always go back and see this small introduction to CloudFormation and what do we mean as perform operations with code, okay? And you can see that there are many different kinds of things in the framework, and we are going to dive deeper and deeper in each one of them. So another thing is annotating documentation. If we ever create a documentation by hand, make sure that we think how to keep it in sync with the rest of the company, because outdated documentation can create quite some damage, and this is stated here in the framework. So making frequent, reversible, and small changes is very important. So you can design your workloads, you can design your CloudFormation templates in a way that you don't have to change everything at once. And a very important part of this is how to design software processes that scale. If we take a look at Amazon at around 2008, there is a very nice diagram of our microservices, and I'd like to show you why this is so important. So here's the thing. So this is a popular image for the Amazon in around 2008 and what it did look like. I was hoping we'd have more, yeah, so this is it. So can you imagine like what it would be if to update something in the Amazon website, for example, to update the basket, the icons in the clothing website, we needed to stop the electronics website or things like this, or to launch a new feature, we would have to coordinate with these many service teams and different applications. And this is a problem, not only, this was a problem for us already 10 years ago at Amazon, but it is certainly a situation that many software developers have been facing for the last years, and generated all this conversation about microservices and maybe struggling today. So this is why it is important to state that we need to think of a process where we can make frequent, small code changes and not to wait for lots of bugs to go live, as this is generally a lot of trauma. And refine operation procedures and frequently anticipate for failures. And here we're going to make very long this theme of exercising and generating chaos and running tests and things like this. Learn all from operational failures. The most important thing is when we find a hole in our applications, when we find a security issue, a reliability issue, and we're going to explore several applications for that, we need to document it, make it such that someone can either learn from it and prevent it on the future, or automate it away, right? And this is the key for operational processes. This is in terms of best design practices, design guidelines. That's in terms of the best practices. So this is what I mentioned when we talked about the questions. So every framework pillar will have this questions. So what factors drive your operational priorities? How do you design your workload to enable operability? How do you know that you're ready to support a workload? This is what the best practices look like in terms of questions. What factors drive your understanding of operational health? How do you manage operational events? So all those things are important to be defined, but in every customer they will be defined a bit differently. So in the specific episode about operational excellence, we'll dive deep into each of those questions and make sure we answer or see how customers might answer each of those questions. and also take a look at the key AWS services. So here in operational excellence, as we discussed, the key is CloudFormation. So we have to see, and we're going to dive deeper into CloudFormation and how to declare more complex architectures. Now today was just a first initial bucket, but we're going to see lots and lots of CloudFormation's tips, tricks, and creating progressively more complex architectures. Then this is actually the last episode on the series. The first one this week is going to be with security. So we're going to talk with Ben Potter and see how do we implement a strong security foundation, how to enable traceability and track changes across several environments, how to apply security in both infrastructure, database, application, and all the tiers that your app may have, how we're going to automate the security best practices into the process. So, for example, code reviews, dependencies, the code analysis, static code analysis, or live traffic monitoring, or everything that can be automated into the process to protect data and services. We're going to take a look at it. How to protect data in transit and at rest, how to encrypt things in transit, and how to use the encryption features of several AWS services to make sure things are private, how to keep people away from data. And this is a very hard thing to do, because sometimes you want to keep just the right people away from data, right? This data must be handled to somebody. And making this difference, it's sometimes hard, because it's not just who the person is what the person is doing. For example, one customer representative, for example, a sales guy accessing one customer's private information, such as his address, in your company may not be a huge deal. It may be a customer support representative doing technical maintenance or things like this. But if you find a customer representative looking up all customer addresses and all history purchases, this may be a fraud or something wrong. So keep a look at the way people access data is pretty important as well. And prepare for security events. So how do you react if you get an outage, for example, is something pretty important to define, or even worse, security incidents. Okay? Well, yeah, and again, everything here will be turned into code. So if we check the security operations, it will be better it will be questions that are more implementable than the operations Spieler, the operational excellence Spieler. For example, how do you manage credentials for your workload? How do you control human access to services? How do you make programmatic access to services? And some of these things you can actually control. For example, how do you manage credentials and human access? You can actually see, like on CloudTrail and other services, you can automate and see if someone logs in as root or access your AWS services in a way that it shouldn't be. You can actually trigger alarms and monitors and react, and we're going to see in the security episode how to set it up. And how are you aware of security events? How you detect security problems in the first place? How do you protect your networks? Do you use like web application firewalls, content delivery networks, private namespaces, addressing spaces, and things like this? How do you stay up to date with AWS security features and industry threats? And this is a pretty important thing to not get caught up in the latest attack. How do you protect your compute resources? So if you have long-running instances and servers that you need to protect, this is what we're going to talk about in the security part. Okay? So how do you classify data, how to manage protection, how to protect data at rest, data in transit, and things like this. So everything related to incidents, security, automation of responses, and things like this. So here we'll take a pretty in-depth look at IAM, and because that's the service that allows you to make security assertions on AWS and control who can perform what operations on what resource. So as we're taking a look at the key services, let's take a look at least open the IAM console and see what it looks like and the most important parts of it. So let's close those other tabs and go to the IAM console. And a couple important things here. First is this checklist, like the security checklist. See, I'm 3 out of 5, so I should be doing better for my own security. Like deleting my root access keys, I already did. Activating the multi-factor authentication is something that I should do. And use individual IAM users and groups to assign permissions and apply IAM permission policy. And the most important thing here is this: create an individual user and don't use the user that you create when running your account. We're going to see more about how can you create these users. But the idea here is that you can create users inside your account that have limited privileges or in this case unlimited privileges to do anything you'd like. So you can restrict who can access your AWS account and your AWS services and under what circumstances. And this is the security pillar. On the reliability pillar, we're going to see how to actually test for reliability and make sure that our applications can recover automatically from failure. And let me show you what we mean by this, right? And there is a very interesting demonstration by Netflix called Netflix Visceral. And they have a very nice, it's a very good demonstration of this point. Here it is. So in this simulation, they show how they managed to offload from 3 different AWS regions at once. So you can see this traffic flowing through the 3 different regions that they use in the US. And you're going to see in In the US East 1 region, they start getting API errors. You can see the error rates growing to 5%. And this is probably, for example, as a result of a new deploy or a new feature or something of this nature. And you see that it starts directing traffic to other regions to slowly let the other regions adapt in demand to the traffic that they are about to receive. And when they are fully able to accommodate this traffic, it's offloaded, then the original region is corrected and traffic is offloaded back. And this allows Netflix to keep running, even if an entire region, AWS region, is down. So here they use 3 different AWS regions, and if either one of them fails, they can move over and back, and nobody even gets a flick. You can keep watching Netflix as usual. So this is what I mean by automatically recovering from failure, and this is something we will automate in the reliability part of the series. Also scaling horizontally, so as those new regions gets more traffic, we're going to increase the resources that they have, so we can not guess their capacity but adapt to the amount of traffic they receive. And all those changes, those failbacks and failovers, will all be automated using the command line tools. So that's the whole point. And try to do, I don't know if something so sophisticated as Netflix have, but certainly something that answers these questions. So how do we manage service limits? How do we plan network topology? How do we adapt to changes in demand? And here you can see that every one will have a different answer depending if you use instances, if you use containers, if you use Lambda functions. But it is always important to adapt to the system changes in demand anyway. So we're going to evaluate that in this episode, and how to monitor resources and how to implement changes, how to push changes through the process. And I hope you see and you get a good feeling of how this series is going to go by now, right? Every one of those will be turned into as specific answers as possible. We're going to code it, show examples, partners, tools, videos, everything that can help you get closer and closer to these answers yourselves. But this is by no means complete, but it should be a good start. So if you know how do you back up your data, how do your system withstand component failures, how do you test resiliency, how do you plan for disaster recovery. So things that you may have planned for the future, may thinking about now, or was not even thinking about, but now you're realizing is important. And you may even have your own reliability questions. So you may add reliability 10, 11, or whatever reliability questions you'd like. The important thing here is to understand the process that we're going to go through. And the same thing for the other pillars. And as you expect, the performance pillar is about architecture performance, not only in the terms of engineering and but in the terms of the performance of the process. So how do you select the proper components? How do you select the proper compute? How you select the proper storage? How you select the proper databases? And trying to create like a map and understanding how these things work together in several kinds of architectures will be the goal of this performance episode. And after that, we have the cost optimization episode to understand the consumption model and what are we going to pay and not pay for things that we don't need, and make a process out of evaluating our billing resources using tags and classify data correctly, so we can understand AWS billing and usage even within the same AWS account, and that's pretty helpful. And you will see that with just the most important cost efficiency resources such as CDNs, using the CloudFront CDN for global caching and offloading the backends, and backend efficient compute efficiency with serverless and containers and things like this can dramatically reduce your AWS bill, right, in the end of the month. So let's see how do we evaluate costs, meet costing targets, how do you plan for your consumption, if you check for data transfers, how data transfer is built, and the whole process about AWS finances are going to be built during this episode. And all right, I think that's it. That covers the pillars, and then there is some part about the review process where you can get us and AWS partners doing the analysis with you guys. So if you want to stick around and do it yourselves and go through this series, we are certainly going through it all together. But if you want some help, we have certainly many resources to help you with your own well-architected review and get it into AWS. So if you're interested in this, please get in touch with the AWS Well-Architected Framework team and we'll make sure that you can get connected with these guys, the very experts that wrote this framework. I would just like to show two more things. The sample answers here in the end, we're going to use those as we dive deeper in the framework. So if you want to take a peek, here we have sample answers, for example, on the factors driving operational priorities. There is evaluating the business needs, the compliance requirements, the risks, and same even more concrete answers for each of the best practices. And other than the pillars themselves, there is this other component of the well-architected framework called the well-architected framework lens. So if you're doing serverless applications, everything will look different to you. Like security is different because you don't have servers to protect anymore. Costs are different because instead of paying by seconds, you pay by gigaseconds in fractions of 100 milliseconds. So this things changes the way you think about the framework. So there is a special document, a lens white paper, to guide you through the most important aspects when doing this specific pillar. For example, let's take a look at the serverless lens, and here we can see the new design principles, new general design principles, but totally focused on the serverless functions that must be speedy, simple, and singular. Things in terms of requests, don't share anything because you don't have a shared file system and things like this. Factor in design for failures and duplicates because you can have duplicate events and invocations and things like this. Reference architectures, everything that you should consider when building serverless apps. So that's the point of the lenses, just providing a much more specific view into the framework, and same thing for HPC. Okay. So I hope you understand now what is the AWS well-architected framework and what are the pillars. I'd like to take this time to show you the document and the structure of the thing. So let's, I hope by now you understand the 5 pillars that we have: operational excellence, security, performance, efficiency, cost optimization, and performance optimization. We're going to dive deep into each of those, into every of those questions in the upcoming episodes. And everything we say, we can track back to this introduction and see what we meant by those areas and questions, or we can dive deep and look into each of the pillars and solve any resource that we have. So this is quite an important resource to any architect building on AWS. Furthermore, we have the Architecture Center, and let me show you guys these other resources that are not directly into the well-architected framework, but may help you quite a lot. So this Application Architecture Center will have some sample architectures for teams such as microservices or Docker or many other architectural trends and individual architectural guidelines and everything: chatbots, Magento, Drupal, WordPress, quick starts. You can get started with several specific architectures here. So in the future episodes, when we're talking about these tools, we're going to use this a lot to launch these reference architectures. And there's lots of videos showing important components and aspects of popular architectures that you might be curious about. For example, how Accenture does serverless, or how Fox does media supply chain. So take a look at those guys. They are the ones actually in the field running those solutions. And on answers, you have CloudFormation templates and other resources to solve many problems on AWS. For example, if we see on security, how do I ensure my AWS account is protected? So there is certainly some best practices and some more information about this specific solution, and usually either a PDF outline, or in the cases where there is actual code, the application templates. For example, the AWS Web Application Firewall can be deployed in front of your web apps to protect from several known application vulnerabilities, and you can deploy it right away with SQL injection and many other protections directly from the deploy solution. And when you click deploy solution, guess what happens? You get to the description of the solution and some alternatives that you have. You can do it with CloudFront, you can do it with load balancers, but in the end you will be redirected to the CloudFormation console where you can deploy that stack. So you see how important it is that you understand CloudFormation, and CloudFormation is the way we're going to talk about architectures, and I'm glad we covered a little bit of it today, and I hope you see the value of this and how AWS Architected helps you demonstrate your architecture is ready. And as we fill out this text and show you the code examples, I hope we get the both worlds. In the first tier, the actual solutions and how to answer those questions. And in an upper tier, how to demonstrate that architectures work, how to demonstrate non-functional requirements in a measurable, quantifiable manner so that you can feel comfortable and confident in delivering the best well-architected cloud applications, right? That's it. So thank you very much. If you'd like to keep in touch, and if you have any questions at all, we are going to use several GitHub repos. I've got this one called GitHub. It's very initial, but let me share with you guys. So AWS. Just answering this question, AWS WARIs on GitHub. This is my GitHub repo for all the code that we are going to use in this series. So this is based on Jupyter notebooks, and it's pretty simple by now, but I hope that as the application progresses, we're going to see a lot more of code, and I will guide you through the notebooks and how Jupyter notebooks work and how to bootstrap and run this yourselves. But this is just to be continued on the next episode. We're going to really get our hands dirty in code and creating those solutions. I hope without any audio issues by then. Thank you very much. See you next time, guys. See you this week with security and Ben Potter. Bye bye.